My name's Michael Neely, and I'm a technical account manager for media and entertainment. And our talk today is about stylized materials for linear content. And I do have a cheat sheet, so forgive me, but I just want to make sure I get all this stuff right for you guys. Unreal Engine is known for being capable of incredible photorealistic renders with industrial strength functionality and extensibility. But not everyone's trying to do super photorealistic renders. And so we believe that you're only limited by your own imagination.
No, we can hear you.
I'm just feeding back. For whatever style or look that you want. And so this talk is aimed at opening the window into stylized materials and a couple of ways that you can achieve them. So what are stylized materials? Stylized materials are basic level non-photoreal, or NPR. They range from a traditional cell animation drawing style to a painterly or even more graphic design-based looks with halftones and line screens. In this example of a Toon shader, there are three components: a light rig blueprint, a material parameter collection, and a Fresnel-based material. If we look at the light rig blueprint, it uses a construction script to grab directional light data and updates the material parameter collection whenever any of these parameters change. So if the light turns, it updates the MPC. This also happens in the event graph. It's the same thing, but it gives us the ability to use movie render queue to output the renders. So for this basic example, I'm only using the light's directional vector parameter and ignoring the color and intensity for now. This second component, the material parameter collection, is basically, it's using the light rig blueprint, but it's sort of feeding into it. And we can update these parameters within the collection. And you can create more than this, but this is the three for this example. And then this is key to feeding into the material. So we're going to use this data in a real-time way with the material. Now, as the material parameter collection data is fed into the material via the MPC node, and let's see, that's this guy right here. You can see that. And the shadows are a result of manipulating the Fresnel function's camera vector parameter and replacing it with the light's forward direction vector. And I'll get into that a little bit. The overall Toon outlines also use a Fresnel function without the need for the data from the MPC, because we're just using the forward vector of the camera itself, which is how the Fresnel function was intended to begin with. Using a series of blends, we can then build up the effect on top of a color or a texture map, whatever you have as your base. So, what is a Fresnel function? A Fresnel function essentially affects the reflectiveness of a surface based on the surface normal and its relationship to the camera, and that the camera's forward vector direction. As the surface normals point more towards the camera, the reflectiveness is reduced, giving the edges more reflective appearance. And using this functionality, we can take advantage to create the stylized look by taking the less and more reflective areas of the Fresnel and amping them up, crushing them to black or to white. Now, once we have that, the basic materials on the left, and a more complex version of the material is here on the right. And what that gives us is we have these little compartmentalized graphs, and we start layering them up with the blend nodes. So I'm just adding the outline via a blend, a darken, with the shadow, and then I'm doing an over for the color to show through, or whatever lines. And then I can get a little more interesting and add in some scratches and another Fresnel, and then I get scratches just on the edge, and I can dial them in with more intensity or less intensity. And it makes it really kind of a useful way to get some pretty dramatic looks without getting into HLSL or C++. So this is strictly out-of-the-box functionality out of the engine, and it's fairly easy to do. Some of the things that you want to look at would be, let's go here, like where do we go from here? I've published a tutorial on this process on the developers community, and I've also published the Stylized Materials pack on the marketplace. So feel free, it's all free. You can just download it, you can go through it yourself, you can pick apart my materials. I've got a QR code for both of these, so feel free to capture that. So whether you're a large visualization studio or an indie game company, I encourage you to explore Stylized Materials and the amazing customization that you can create with the Unreal Engine. Now for a glimpse into their journey, I'm going to turn it over to Mr. Martin Walker, Chief Technology Officer for Digital Dimension, to talk about their approach to stylized materials for linear content projects. Thank you.
Thank you, Michael. Thanks for making all that material available and that tutorial available as well. Let me just find my presentation and start this. There you go. So I'm going to go through a lot of stuff real quick, so stay awake. I know it's the end of the day and everybody wants to go party, but just hold on for a little bit more. So Digital Dimension, who are we? So we've been around for 25 years. I'm just going to take a couple of minutes to present us. We've been around for about 25 years, started in VFX 25 years ago, started doing some cinematics for games, and a bit less than 10 years ago, started doing just like animation series, mostly for kids for now, but we're working on some adult ones right now. And about like 6-7 years ago, I'm going to say, we started really exploring using Unreal to do like full animated series. So there's two of them here. Safari, which was released in 2018, was done entirely final pixel in Unreal. Actually, all the videos you're going to see today, it's final pixel out of Unreal. So 52 episodes, 11 minutes, done in Unreal. And then a couple of years later, we released the Beach Buds, which is being, I think, published by Disney in Asia. The first one was done for NBC Universal. So since then, and we're working on a third one right now, a third animated series, again for kids, but we've done a lot of like pilots and demos for some of our clients that are trying to find funding. So I just want to show you a small video of this stuff. There's a bit of sound. There you go. So this is Safari, the first one, the first title. This is all out of Unreal, final pixel. We were using the foliage system here to create all the jungle stuff. This is Beach Buds. Again, final pixel out of Unreal. All the effects were done in Unreal. So what we've done since is we've actually created our entire pipeline based on Unreal, right? So everything is automated, like typical animation pipelines are automated, but we've actually integrated import-export, automatic import-export in Unreal. We're doing layout in Unreal. The only thing we're not doing in Unreal is animation and some modeling, but all the shading is done in Unreal. All the environments are built in Unreal. All the VFX, the lighting, and final polish, the camera, DOF is all done in Unreal. The blue boxes are basically all the stuff that we're doing in Maya, right? So interesting slide to take a look at. What we've started doing is working on our own IP, Chase and Catch. So a lot of the material you're going to see in this video is Chase and Catch. What we were trying to achieve from a rendering standpoint, aside from a PBR-based thing like you just saw in the video, is more of a animation, like 2D animation style, right? We're trying to reproduce the 2D animation styles of cartoon, Saturday morning cartoons. So, and that's what got us into stylized shaders or stylized materials. So just a quick I'm just going to go very quickly over some of the stuff. I'm linking to some stuff that you can find online because I don't have the time in the presentation to actually present it. So different levels of shaders depending on how deep you want to go into the rabbit hole. The large collection of material nodes, Michael has just shown you what you can do with the material nodes that are straight out of like Unreal. There's the custom node where you can inject some small little HLSL snippets. And then if you really, really want to go deep into the rabbit hole, you can come up with your own custom shading model by modifying the game engine code, right? But there's big warnings and disclaimers with that because you have to maintain that and you have to carry it over to the new versions of the engines, right? And unless you know what you're doing, that can be a pretty complicated solution. So actually, show of hands, how many of you have actually used HLSL? Okay, and how many of you have actually modified the game engine code? Oh, wow, a couple of them. That's cool. So don't be scared. I'm not going to show any C++ code, and I'm not going to deep dive into the engine code for this stuff. So we've covered large collection of material nodes. Michael did a good job with that. I wanted to talk about like injecting HLSL with the custom node. So here I just have a very simple implementation of Sobel filter. You can find that online if you just search for it. So you can see on the left-hand side there that little snippet of HLSL, and it's all there. And you can add inputs and outputs to that so that you can drive some of the variables inside of the HLSL code. So it's as you can see, it's a very simple material with the HLSL embedded into the custom node, which is the Sobel node that you can see there, the highlighted node. If you want to do this with custom nodes using standard materials and standard nodes in Unreal, this is what it's going to look like, right? So maybe sometimes a bit of HLSL is not that crazy, right? Because trying to keep this maintained and tracked and versioned can be a bit overwhelming at times. So the other node I want to talk about is the scene texture node. So the scene texture node, and there's a list there on the right-hand side, which basically shows you all the kind of like screen space textures post-process that you have available to you. So you can do a lot of stuff with these things just by grabbing those textures and actually doing some processing on it, which is actually what we're doing here. If you see, we're taking a scene texture and we're running some HLSL code to do kind of a screen space effect, which is the Sobel filter, and then just like pushing that out as a render node type thing. So a lot of interesting textures and render targets that you have there. You can play around with those. There's a lot of interesting ones. The base color one is one of those that we use a lot. The other one that we use a lot is the I can't see there, the world normal one, and the actually depth buffers as well are really interesting type of textures that we can use off of the scene texture node. So let's come back to stylized shaders. This is kind of like the resulting target we're trying to create. Again, the objective is for us to come up with a 2D animated result using a 3D renderer, right? So a couple of buzzwords here. We're using post-process materials blended through the post-process volume. And post-process materials, post-process volumes are screen space effects, right? So they affect the whole screen. You can kind of localize the effects by using custom depth stencils. Again, buzzword inside of Unreal. You can take a look at that. That link there is actually a very good video that basically explains and shows how all of this works together. So, post-process materials, the custom depth stencils, and stuff like that, right? So you can take a look at that. It kind of like explains the whole mechanism. And that's kind of like most of what we've done is based on this type of process, right? So if we take our character, by the way, I was talking about really going down the rabbit hole, we went deep, deep, deep down into the rabbit hole. So we've customized our own version of the Unreal Engine. We've actually created our own material nodes that basically produce post-processed material, textures, or whatever. So if you look at the material and the shading model, we have a stylized shading model that we've added to the process, right? So, and it's kind of like cut into four pieces, sorry. There's 3 nodes there, and we'll talk about the rim lights at the end. But there's kind of like the stylized shading, which is the, kind of like cell shading plus plus. There's the line art, which we're going to get into, and also kind of like a custom shadow that we've actually built for the purpose. So if we look at the first node, just taking a look at these nodes individually very quickly, the purpose here is we want to try and flatten the light as much as possible, right? So when I say flattening the lights, we're basically, if you take a look at the spheres at the bottom there, if you look at the second one, what we're doing is we're taking the actual, I guess, the Fresnel and flattening it, right? We're taking that gradient and we're applying a curve, like we're using the curve editor for that. We're applying kind of like a staircase curve to it to be able to create what we call Toon bands, right? So, and that's the first step. And then the second step is we do the same thing for the specular. So we can flatten the specular as well. And the objective there is to remove the perception of depth as much as possible, but still preserving the kind of like the gradient of color as we're going through the model. So what we wind up with is kind of like what you have on the right-hand side there for the character, is a very flat model. Again, the textures are solid textures. And by using the Toon banding and all that stuff, you get kind of like a very flat colored character. But we wanted to do more than that. So what we did is, and the line art here is a bit exaggerated just for demonstration. So the stylized line art, all it's doing is basically 2 things, right? One is figuring out the contour of the character. So here's where we're using the depth buffer and applying kind of like a modified Sobel filter to be able to figure out the outline rims. The inlines, what we call the inline art, we're actually using a Sobel filter applied to the normal map, right? The world normals. So, and a Sobel filter, by the way, is used in imaging to find edges of objects based on what they call data frequency. So if there's high contrast between two objects, it's going to define that as a line. So applying this to the depth buffer, if you're looking at the typical depth buffer, it's basically going to find all the edges of the objects. And if you apply it to normals, right? Again, the normal map, it's going to draw lines whenever there's a big difference in the normal directions, right? So the added trick here that we had to modify the engine for was we created kind of like a custom color in materials to drive the actual line colors in the objects, right? You can override those using the line art color in the actual node, but we wanted that color to be driven somewhat by the actual texture of the meshes, right? So that we can get the proper color of those lines. The lines vary if they're in shade or if they're in light. We can actually add a texture to the line to make it look like a pencil drawn and all sorts of stuff like that. So, and the other added effect is that we vary that line texture as a function of distance to the camera. Because if you have a thick line on an object that's close and you push it back, well, if that line thickness stays the same, you're not going to see the character anymore, right? All you're going to see is lines. So, so we've added all that functionality inside of the game engine per se. The next one is the Stylized Shadow. Again, all of this is about flattening some of the light effects, right? So flattening the actual light fall off. It's a mask that we create, again, one of those scene textures that we're basically applying post-process. It's a standard Fresnel implementation that we flatten for 2D effect. Again, it's kind of like driven with the curve editor, so that we can really customize the light fall off and get the actual flattening effect, but maybe softening some of the edges a bit. And it's kind of like separated in two pieces. There's the self-shadowing, which is based off of the diffuse, and there's the projection shadow, which we don't see in this drawing here. But we can basically apply a different technique to the actual projected shadow, right? And again, like mentioning here, the hatching itself is just basically a texture that we're supplying to be able to create some ragged edges if we wanted to. We don't have it in this example, but we can create kind of like, the typical hash that they have in drawings and cartoons. The last thing is the rim light. It's not really a material node. It's actually a custom rim light, right? So again, modified the game engine. We came up with our own custom spotlight implementation. It's got all the typical variables and parameters that you can recognize in typical spotlights. We have two implementations of it, diffuse, Fresnel, depending on what kind of effect you want. Again, we can control we love the curve editor in Unreal. We love the atlas as well, if you guys know what an atlas is. So we're using the curve editor again to control a bit of the light fall off. So we can make it really hard edge or really soft edge from the light fall off. But again, it's a question of really flattening that light, right? Really getting rid of the perception of depth as much as possible. So controls for the rim light, thickness, intensity, opacity. We have our own, obviously our own set of parameters that we can customize with that rim light. So when you put all of this together, take all of those layers and you combine them and you blend them through the post-process material pipeline or post-process volumes, you kind of get your final character there on the right? So you take all of those, you combine them, and you get kind of like the effect that you want, right? So of course, we're programmers. This is programmer art. I'm going to show you a couple of videos that were actually done by our artists. So throwing that to the artists, and they can really have fun with it and really play around with it. So the first video I'm going to show you is just a model that's rotating. It's kind of like a turntable model, applying different types of shaders. And pay attention to the second one. There's 3 of them. The second one, we'll talk about that one later in the presentation. This is an interesting effect. So I'm just going to stop the video here and just show some of the, all the, oh man, the video stopped. Oops. Go back, see if I can get it again. There you go. Close up. So when you're looking at this one, you can see all the line art that's showing up. It's colored, so it's following the color of the texture. The rim light that you're seeing here, a lot of the shadowing effect. It's all very subtle and all blended together, but the idea is to try and get something that really looks 2D, and you can really see it in the shoulder here. You can see the rim light and the shadow actually following the rotation depending on the light direction that's hitting the character. So we pushed this a bit further, and we basically ran some. Did I just mess the whole thing up? Yep, I think it blew up. Boom. Windows. Sorry about that, folks. Windows and PowerPoint. No, that's yours. That's mine. Let's go back to where we were. There you go. Always a mishap, right? But that's okay. We've gone over it, so now we're not going to have any more. So we basically pushed it further and ran some animations with this stuff, just to take a look at how the shadows follow, how the lights follow, how the line art follows. It's really interesting what actually we can accomplish with this. So, thank you. Again, all of this was final pixel out of Unreal. There's no layering, there's no comping happening. Our objective is really to get the final pixel out of Unreal. One last thing I wanted to show you, we've been playing around with and I hope I say this right, the Kuwahara filter. Did I get it right? My French accent wants to kick in and say something else. So we had fun playing around with this, and the video I'm going to show you, and I'll stop it probably a couple of times and show you some of the stuff, some of the effects that we're getting out of it. This is actually a metahuman that we basically costumed and animated, and we wanted to see what kind of effect we could, like gritty effect we could get using metahumans, because metahumans are meant to be realistic, right? But we wanted to see how it would behave by applying something like a Kuwahara filter. Again, 2D filter, screen space. This filter is usually a denoiser, used as a denoiser. But if you play around with the parameters enough, you can get some really nice, cool painterly effects. So we'll just start the video. There's no sound to this. We're really trying to get a very specific look out of this. And if I'll let it run, and then we can pause it and take a look at it, and hopefully PowerPoint won't blow up again. So let me pause this. So some of the interesting effects are like the fur the metal plating, you can see like all the lighting kind of like texture that it's got. Specifically, the characters in the background are almost dissolving, right, based on that screen space effect. We got a bit of DOF running into that as well, but like it's really giving us a very clear, particular style, and really like how it works out with the face as well, given that it's a metahuman and it's meant to be a very realistic render that we've basically just textured with the Kuwahara filter. So yeah, so this let me just play this again. It's really cool. Again, metahuman that we costumed and animated ourselves, and just applied some of these filters on it. So that's kind of it. I'm just going to go to the next slide. So a bunch of, I'm going to leave this slide so you can take pictures or whatever. I got a bunch of links here. Well, the first two are from the actual Epic Games community site. Really a lot of interesting stuff that you can find there. One of them is the material masterclass. It's based off of 4.20 something or other, but it's still applicable to a lot of the stuff that we do in Engine 5. It's very exhaustive. It covers all the features. It covers the custom nodes. It covers post-process materials and volumes. It covers all of it. Takes hours, but it's really worth going through all of it if you really want to understand how far you can push materials inside of Unreal. The other one is post-process effects. Again, it's all based on post-process materials, post-process volumes, how to basically use those features inside of Unreal, and how to be able to, again, push the materials specifically for post-process effects. I got a couple of links here on the Sibel filter and the Kuwahara filter. I'm still saying it wrong. I got Wikipedia like references if you really want to take a look at the math behind it. It's really somewhat complicated, but if you really want to understand how the math works. And then there's a couple of links there on people who have actually used it inside of Unreal. Really interesting, actually. So the first snippet of HTML I have when I'm talking about the custom node actually comes from that link, right? Didn't invent that, just took it there, just copy pasted it, and did that in about 5 minutes flat type thing. And there's a couple more links tied to that YouTube video for the Kuwahara filter. So really interesting stuff. That's it for me, I think.